Hi, welcome to the ExcelWorks series of video tutorials. In this video, we'll continue to demonstrate the use of the integration function QUADF in the ExceLab add-in for two more examples. The focus of this video, however, is to show how to use Excel features to define more complex functions, which would be difficult to represent with simple formulas. Let's begin by starting Excel. Our first example is a function comprising a summation of a sequence of sign alternating terms. To define this function, I'll start by generating a sequence of numbers from 1 to 12 in column C. Using the auto fill features of Excel, I can drag this little box here down to 12 to generate the rest of the numbers. In A1, I will write the first term in the sequence as a formula. Referencing C1 as my index and using X1 as my variable. To generate the rest of the terms, I can again use the autofill feature by dragging this little box here. But as you can see, we have a problem. Here Excel has incremented both the index C1 as well as the variable X1, when in fact we need to hold X1 fixed since it represents a variable. To fix this problem is quite simple. In fact, we will delete the sequence of terms and modify our first term to lock the variable X1 by adding a $, which is a standard Excel feature. Now, by generating the rest of the term, Excel does not increment the X1 because it's been locked, and this is the desired outcome. Having generated the sequence and the terms, it's straightforward for us now to define the function fx. We pick up cell E6 and define our formula for fx as follows. Using the built-in function sum, I can specify the range A1 to A12 to complete the definition of my function. Notice that f of x, the cell E1, E6, which holds a reference to the function f of x, has implicit dependence on x1. Now, to integrate f of x, it's actually quite simple right now. All I have to do is invoke QUADF, passing in a reference to my function in cell E6. My variable of integration is x1, and my limits, let's say, from 0 to 3, and this computes the integral. Let's move next to the second example, which includes a function with multi-definitions across its range. We can define this function as a one formula in Excel, although it will be a little bit long and difficult to manage, so I'm going to break this down into over multiple cells. This definition uses two constants, R and D, so I'm going to begin first by defining these two constants. I'll pick cell D1 to define D and specify the value 1000 as described here, and I'm going to use C for R and specify the value 6300. To help readability, I'm going to rename these cells as D and the cell C as R0. I could not use R because R is a restricted name in Excel. Now I can refer to D and R0 inside my formulas. Next, I'm going to define the first sub-expression of f in cell A1 using x1 as my variable, and I'm going to define the third sub-expression of f in cell A2. Since it's very similar to the first one, I'm just going to copy and paste and add pi to it. Next, I'm going to construct the multi-definition function in cell B5 as follows, using the built-in f function. My logical test would be to compare the value of my variable x1 to d over 2, and if this is true, I will return the value of cell A1, which represents the first sub-expression. If this is false, I have to do another logical test to discriminate between x equal d over 2 and x greater than d over 2. So I'm going to insert another f, and my logical test here is if x1 equal d over 2, I'm going to evaluate to pi over 2, and otherwise I'm going to return the third sub-expression, which is included or defined in cell A2. My function now is fully defined in cell B5. Let me show the entire formulas so we can better see what's happening. So A1, and let me bring the image closer so it's visible for us. So my function reads as follows: if x1, my variable, is smaller than d over 2, then return the value of a1, which has this formula. Otherwise, check the value of x. If it's equal to d over 2, then return pi over 2. Otherwise, return a2, which is this formula. Having defined the formula in B5, now it's very straightforward for me to integrate it. All I have to do again is invoke QUADF, passing a reference to the formula in B5. My variable of integration is x1, and my limits could be from 1 to 5, and I have to switch back the values. So this is the value of the integration. This concludes the second example and this video as well. I hope you find this video helpful. Thank you for listening, and please continue to check excel-works.com for updated videos and information.